Like if I took an inventory of what I had with this question, I'd have 3 big squares and then 6 rods. Squares. You know what I mean? And so you got to build a perfect rectangle and then read off the side lengths. That's all you're going to do, right? So we're going to write, here's a square, there's a square, there's a square, okay? And then you need 6 rods. Well, it looks like I can fit 3 across this way, and then I can fit another 3 underneath. Okay, well, after that, I want you to tell me what the side lengths are, right? Because that's what we're trying to do here. You've built the area, which is good, right? That's what we just done. Now I want you to read off the side lengths. So it looks like I can fit 1 rod here and 2 squares. And then I can fit a rod this way, another rod, and another rod. Okay? And so if I were to like count up the pieces, that's an X, that's an X, that's an X, this is an X, and that's a 1 and a 1. It looks like I have 3 X's along the top, and I'm multiplying that against X plus 2. There's an X, and there's 2. Okay? Does anybody have any questions? Again, that's the same thing as going identifying. This one's a little trickier because we've got 2 things going on here. If you look at this question, we have what are called coefficients. You have numbers. That's what coefficients are. Okay? And then we have unknowns. Those are what we call variables. Okay? The 2 combined create what we call a term. We have 2 terms here. Okay? Now, much like what I was trying to get you to do earlier, you guys can recognize, well, I could pull out a 2 from both of these, right? Well, when we go down here and look, it looks like, okay, well, that's fine. I can take a 3 out of both, right? So I can take the 3 out. But then it also looks like, oh, well, there's an X sitting in both of them as well. So it looks like I can take out a 3X. Or in other words, like I can divide both of these. I can divide both of these pieces by 3X. Okay? I know because I know I can do that because look, I can see the X's are going to cancel, and X here is going to cancel one of the X's in the top, right? Because remember what I said earlier as well, you can rewrite this. You can rewrite X squared as being X times X. So if I did that in the top, it would look like this. 3X times X over 3X plus 6X over 3X. Okay? Now, although this looks like it's more work, it might be a little bit more confusing relative to this. If you do 10 questions, like substitution, it will make sense and it will be faster than drawing the area every single time. Okay? So don't forget about the fact that if I decide to divide by whatever, in this case I've decided to divide by 3X, I can't just decide to divide by 3X and have no consequences, right? You've changed what's gone on there, except if you multiply by 3X as well. Okay, so this is what you've got. You've got 3X, everything is multiplied by 3X, and then you're also dividing everything by 3X. So that's 1. But what it's essentially allowing you to do is simplify what's inside of the brackets, right? And so if I look at what's gone on here, one of these X's cancels with one of those X's. 3 divided by 3 is 1. right? So I'm going to rewrite 3x as 3x multiplied by 1. And then all I'm left with in this piece is this an x left. And then 6, you can see here, x cancels with an x. And 6 divided by 3 is 2. So you can see this answer, again, matches this one. This is kind of the more algebra side of things, right? Whereas this is kind of the concrete. Here, I'm going to get rid of this. This is kind of like the concrete, or building. Like we're building the representation, right? This is what I'm saying, is you do questions today, you're 100% free to draw, and you're 100% free on the test too, to use what's available to you and what I've shown you. Okay, if you want to draw pictures and do the work that way, that's fine. Okay, I'm not going to say you have to do it the way that I'm saying down here at the bottom. I'm trying to give you multiple tools, okay, to figure this stuff out. The problem is when you look at, even looking at the next question, I don't want to have to draw 14 rods, right? You don't want to either. And so having this algebra skill kind of makes life a little bit easier. So if we come down here, I'll do the next two with algebra because I think I've done enough with the building of the tiles. And I don't want to draw 14 rods. So let's just take a look here, okay? So I'm looking at both of these two pieces, or terms, okay? Okay, that's the terminology that we're using, okay? Terms. I got two of them there. I'm going to look at them and I'm going to like, okay, well, what's similar about them? In the sense, what could I divide both of them by equally, right? We saw earlier, well, I know I can divide 14 by 2. So, and remember, if I divide, I have to also multiply, right? So this is going to turn into 2. You're going to open up a bracket, and you're going to tell me what's left after you've divided both of those terms by 2, right? So I'm just going to rewrite this. Right, and then we said, okay, well, if I'm going to divide both these by 2, that's what we're going to do, okay? Now, it also looks like there's an x in both of them, right? And so I could probably divide both of them by an x as well. Well, if I divide by an x, I better put the x out front as well, right? You can see whatever goes here has to match this. Okay? What we're doing is what's called finding the greatest common factor. Okay? I'll write that out in words. Okay, or GCF. Okay? You're trying to find the thing, it's a factor, it's a thing that goes into both of them. It's a piece. Okay? It's the biggest thing that goes into both of them. Greatest. And greatest common piece, I suppose, would be the way that you could alternatively say that. In this particular question, 2x is the greatest common factor, or greatest common piece amongst the two terms. Okay, and so all you have to do at this point, as soon as you identify that this is the greatest common factor, then you just go 2x and tell me what's left after you do the division or canceling of each of these. So 2 cancels with 2 because 2 divided by 2 is 1. X squared, there's 2 x's in the top. One of them cancels with the 2 in the bottom. And then 14 divided by 2 is going to be 7. And then the x's cancel. Okay? So what we end up with is, I only see an x there. so an x. And then 14 divided by 2, 7. Okay, does anybody have any questions? So what we're doing is we're calling, we're going to call this common factoring is what we're doing here, okay? But you can see I'm just assigning a name to a process, right? You can see this is all the same work. It's coming up with the area and then writing the length and width. This here this is length times width, right? Where w plus 7 is going to be the width and 2x is the length. We're just coming up with areas. Okay. So as we go through here, I just want you guys to kind of start moving towards the algebra if you can. Okay. So right off the top, I'm going to identify the greatest common factor. What's the thing I can divide both of these by? Well, let's look at them. Okay. I think 3 goes into 9, right? So 3 times. So it looks like I can divide both of these by 3 at least. And again, I see an x in both of them as well, so I can divide by 3x. So my greatest common factor is 3x. So if I were to try and simplify this then, I could rewrite it. If I'm dividing both of these by 3x, then I have to write a 3x out front as multiplication. And then you just tell me what's left after you do the math on this. So you should get x plus 3. Okay, does anybody have any questions? So down here, we're starting to see why we're changing the terminology, okay? So factoring means, or to factor, find the factors at which we can multiply together. Okay, so when we say length times width, right? Right, we're trying to find the pieces that we can multiply together to give us the area. Okay, and so we're going to get something that I'll write you something here. Okay, so to get from here, this is our area model, right? This is area. This is length times width. So to get from here to here, we call this factoring. Okay, to get from here to here, we call this expansion. We call it expansion, right? Because we're going to get rid of the brackets in expansion. Okay, we're actually doing length times width, and we're going to produce this. You're going to see. Okay, you guys copy that. That's kind of an important one, actually. It keeps what we're doing straight forward in your head, right? When I'm moving from, remember we called this from yesterday, we called this standard form. Okay, that's a type of parabola. Okay. So, again, it's just defining some things here, okay? So, here's what we want to do now. Keep saying build rectangle with an area for the reason that that's all we're doing. No matter what we do, we're throwing new words out. We're always trying to find the area and length and width. That's all that's happening. Okay? Despite us using new words, these are what these new words mean. Right? Expansion and factoring. They're just different directions. They're opposites. Okay? It's multiplication, division. Right? Okay? That could be a way for you to think of it. They're opposite processes. Okay? To go from one to the other and back forth. Right? So expansion is multiplication. We're going to multiply those things out. We're going to see how to do that in a minute. And then factoring is kind of like you could see me dividing all the time. Division, division. Okay? So, just want to come take a look at this one. We could build this area. Okay, and it's saying we have 3x's. 3x squared and 9 rods. Okay? And basically, you guys could build the area and then figure out what the side lengths are, but you could also just look at them and go, okay, divide by 3x, divide by 3x. That looks right. I think we just did this question actually, so I don't know why it's here again. But again, we're going to get 3x out front, and we're going to write x plus 3. Is it going to be in its length times width version? Okay. If I look at the next one's a little bit more challenging because we have not 2 pieces anymore, we have 3 pieces. But the principle still applies here. Okay, I'm just trying to find something that goes into all 3 of those things instead this time. Okay, the catch is I see an x here, I see an x here, but I don't see an x here. Which means my greatest common factor, if I were to write this out, if I write out the greatest common factor, it's not going to have an x in it, right? But it will have a number because it looks like all 3 of these can be divided by 2. Right? I could divide all of these by 2. I can't divide them all by 2x because there's no x here to divide by. So you don't include it. You can only divide by 2. So our greatest common factor is 2. When we do that, we can say 2 out front, and then we get x squared minus 2 plus 1. 2x, sorry. Right? Everything inside of this bracket is just from 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. And 2 divided by 2 is 1. Okay, factor is saying what do the 3 terms have in common? Okay, I would anticipate there's probably some questions of this stuff. There's no way that this is going into everybody's head all at once. There's no way. This is a hard concept. It's okay not to understand it. Okay, all the stuff that we've done today. Okay, I'll find out when we do a formative, right? If you have any questions now, you can ask. Okay. That's all of everything we've done now is factoring. Okay. What we call factoring. Building the area and then finding the length and width is what's called factoring. Finding the length and width. Okay, you're finding the length and width from the area. That's what factoring does for you. Okay, what we're about to do is the exact opposite, and I've kind of hinted at it as we've gone through here, is now we're going to expand. This is typically the one that most people are actually okay with. It's the factoring that people struggle with. Okay, and I'd imagine I'm probably going to spend a little more time on factoring, but everybody should maybe get the expansion a little bit faster, I think. Okay, so we're just going to here's what we've got, and with the expansion is nice from the standpoint that you guys already know how to do this. Okay, we've told you with expansion what the length and width are, and I'm asking you to produce the area this time. This is the multiplication. This is the exact same stuff as doing 12 times 15, and you write the table down. Okay, the catch is this time 10s are not the x's, they're x's, right? So when you write the table out, you're not going to write 10, you're going to write x, right? So by that I mean, let's just write these things out. X plus 2 goes across the top, and then we'll write x plus 1 down the side. Fill in the middle with multiplication. How do you fill in the middle? X times x should be x squared. I'll build one of these for you in a second too. I'll have to stop the video though. X times 2 is going to be 2x. X times 1 is x. 1 times 2 is 2. Okay? And then, what did we do when we did this? Here, I'll just do this one for fun. 10 and 2, 10 and 5. We fill in the middle. That's 100. That's 20. That's 50. And this is 10. You remember we just added this all up. We got 120 plus 50 plus 10. Here, I'll do this with all 4 pieces so we don't lose anybody. 100 plus 20 plus 50 plus 10. 0, 2, 7, 8, 180. You do the exact same thing here. X squared plus 2x plus x plus 2. This is what we call, and you already know how to do this, collecting like terms. Okay, I can't leave it like this because I see that there are 2 things here that I can add together. Remember what I've got here. I've got a big square. I can't add the square to a rod, right? But it looks like I have 2 rods, and then I have 2 little cubes at the end. They're squares, right? So you can collect the like terms, and you're going to get x squared plus 3x plus 2. That's your final answer. This is the area for that length and width. Okay? I'll try doing one now, okay? I'll stop the video here. Okay? And maybe I'll build this one with you guys, okay?